a part of this equation. Whatever is your output, then that output will be changed into this power. Now, question 3, won't even look at this because it was formula given, Kelvin was on the whiteboard, and some of you used temperature, no temperature. Anyway, check their nose. How to do it.
Whoa.
Question 3.
That's not fair.
Otherwise, I will stop reviewing.
Oh, sorry.
Most of this question in your notes. Check the notes. I'm stopping at the question where was kind of different from the notes. Now, that one, again, that example in your notes. You somehow missed it. I'm going to stop on that one because this is kind of, I don't know why, giving you trouble. If starts 10, stops in 10, what is the span? 90, right? 90, 100 minus 10. This is 90. 90 divided by 10, each step is 0.9. That's how you find. Now, how you find the frequency? From the period. You know the period. And be smart. Engineers, don't use small period to calculate things. Just take into account everything. 1 period, second, that's the distance. Biggest distance. That time divided by 3 periods, that will be your period. More accuracy. Next time you measure in something, use bigger space. And that bigger space, that's the bigger space. And you can see there's 3 periods in this. Whatever the time for it, divide by 3, and that will be your 1 over t, your frequency, and then frequency according to that steps. Be careful. Again, I was explaining a lot this. Power from the voltage. Again, RMS. RMS. When you're calculating the power, it's RMS. It's now 7 harmonic. Question about 7 harmonic. Again, question from your notes. And some of you decided to find 7 harmonic like this. 1, 2, 3, 4, 5, 6, 7. Which is not 7. This is 7. The second is absent. 6 is absent. But 7 harmonic, that one. You divide amplitude by 7. Basically, you demonstrated that you wasted your time in CR255. Now, pole, order, roll off. It's all from CR255. What is the pole? Single unit, RC unit. That's the pole. Hardware, circuit. What is the order? How many that poles in it? You have 2 poles, it's the second order, and so on. Roll off. How fast voltage goes down with frequency. Okay, that question, again, nothing. It's ECR 255 and okay. Guys, some of you missing algebra skills, converting that formula into this formula. You're forgetting that if it's square root, f squared, pi squared, and 2 becomes squared. Somehow when you're going from C to F, you're forgetting about conversion. Nothing to do with the CR, it's your high school skills. Missing. And from this conversion you find C. I found some of you guys, especially maybe it's a Chinese format teaching you, don't plug any numbers until you finished conversion. You got new formula and then plug the numbers. Because some of you doing strange things. They putting numbers here, and leaving this L, calculating, then rearranging again calculating. First, find the formula, and then plug your numbers in the formula. It will be much faster and less prone to the mistakes. Okay, cutoff frequencies. For the cutoff frequencies, you check the Q bigger than 10, then you can use simplified form. How to find bandwidth? You have frequency, resonant, you have Q. That's your bandwidth. Simple. That question from ECR255, nothing else. Yeah?
No one.
You have your cutoff 1 and 2. That's the graph. You don't need to invent. Some of you inventing new points. It's everything's here. Where's the 1K? It's a 10K. This is 1K. Where is the 2 meg? This is 1 meg, and next line is the 2 meg. That's your cutoff. When it's gonna happen? At -3. That's the point 1. That's the point 2. Now 10 times -20 decibel. 10 times
Be 20.
20 decibels. 10 times no change. 10 times no change. 1, 2, 3, 4, 5, 6 points. Enough. Some of you doing that strange things. The line goes here and then turns. No, it continues going down. Another decade it will be 40 decibel, another decade will be -60 decibel, and so on. Don't do this thing. And then phase shift. Yeah? This is this cutoff frequency for the high pass filter, and it's a behavior for the high pass filter, plus 90, 45 at cutoff, and then 0. No change, no change, no change. And then now it's a low pass filter. For the low pass filter, no change. -45 at cutoff, and -90 for this one. Again, this is from ECR 255. And most of you failing ECR 255. I don't know why you taking COM455 without. Anyway, okay, that one again. That's from your notes. You just need to multiply 2 gains and see the result. Here you have bigger than 1. That will be clipped, kind of square away stuff. Okay, less than 1, dumped. I have words and I have illustrations. Equals to 1, that's our baby. It has stable sinusoid oscillation. Braghaus, okay. Have to be, I left bigger than 1, because if it's bigger still it's oscillates, yes, clipped, but still oscillates. I left it here. But for our carrier, that's the most important case. And some of you giving the right answers and forgetting about the phase shift. That's have to be 360 degrees or multiples. This 3, just for some reason, I don't know, maybe it was too late, I copied and pasted the same thing. I was thinking about copying copies, but in my clipboard was that one, and I just copy and paste, and I didn't notice this. And that's the right answer in this case. If you say same, of this was right answer. Somehow you missed to get the point for this one. Okay, the duty cycle, that was the most simple. Most of you did it, but some of you didn't do this right. I don't know why. If you just look at this, that's the period, 1, 2, 3. 1/3 of this. I don't need any calculations. 1/3, and then duty cycle.
It should be just 33%.
Yeah, 33. Why it's 1, 1, 1, 1? 33, right, 33. It's just maybe from another version. 33. And you have your 33 marked as the correct answer. Maybe I was thinking about changing this duty cycle. 33.33 for that one. Okay. Done.